Stack data structure. Stack follows the last in first out principle. This means that the last element we put into the stack will be the first one to be removed. Imagine a stack of plates piled on top of each other. You can add a new plate to the top of the stack and remove the top plate easily. To reach the plate at the bottom, you need to remove all the plates on top first. LIFO principle of stack. In the context of stacks, we use the term push to add an item on top of the stack and pop to remove an item. As you can see in the image provided, despite item 3 being placed last, it was the first one to be removed. This exemplifies the core principle of the last in first out behavior in stacks. It's worth noting that we can implement a stack in several programming languages, including C, C++, Java, Python, or C#. The stack's fundamental specifications remain mostly consistent across these languages. The fundamental operations that enable us to perform various actions on a stack. Push. This operation involves adding an element to the top of the stack. Pop. With this operation, we can remove an element from the top of the stack. Is empty. This operation serves to check if the stack is empty. Is full. By using this operation, we can determine if the stack has reached its maximum capacity. Peak. The peak operation allows us to retrieve the value of the top element without removing it from the stack. Working of stack data structure. We use a pointer called top to keep track of the top element in the stack. During the stack's initialization, we set its value to -1, which allows us to check if the stack is empty by comparing top equals to -1. When we push an element, we increment the value of top and place the new element in the position pointed to by top. When we pop an element, we return the element pointed to by top and decrease its value. Before pushing an element, we ensure that the stack is not already full. Before popping an element, we check if the stack is not already empty. Stack time complexity. In the context of an array-based implementation of a stack, the push and pop operations exhibit constant time complexity, denoted as big O of 1. This signifies that the time required to execute these operations remains unaffected by the number of elements present in the stack. Applications of stack data structure. The stack, despite its apparent simplicity, proves to be an immensely powerful data structure, finding diverse applications in various domains. To reverse a word. It efficiently reverses a word by utilizing the push and pop operations to rearrange the letters. In compilers. Compilers employ stacks to evaluate expressions like 2 + 4 divided by 5 by 7 - 9 by converting the expression to either prefix or postfix form. In browsers. Browsers use stacks to manage the back button functionality, storing the URLs of previously visited pages. The current URL is added to the top of the stack, and when the back button is pressed, the current URL is removed, granting access to the previous URL in the stack.